Hello everyone. So in this video we will be discussing a coding problem, squares of a sorted array in Java. So if you see, in this problem we are given an integer array which is sorted in ascending order. So here you can see this is the input -4, -1, 0, 3 and 10. So it's sorted in ascending order. Now what we need to do is we need to return an array of integers such that we need to square them, and whatever is the outcome we need to simply return that array. So for example the output would be 0, 1, 9, 16 and 100. So how this output came is, after squaring each and every number you will see the array will become -4 into -4 will give us 16, -1 into -1 will give 1, 0 into 0 will give 0, 3 into 3 will give 9, 10 into 10 will give 100. So this is the array which will be generated after we square each and every element. Now the complexity part is we need to sort this array and return from the method. So after we sort this part, it will become 0, 1, 9, 16, 100. So friends, the brute force approach would be we simply square the array, so it will become like this: 16, 1, 0, 9, 100, and then we again use arrays.sort. We pass in the array and we get this result array. But this is a brute force approach which is not very efficient. So if you see, at the last step if we sort the array, the time complexity will be n log n, so which is not good. We need to see that whether can we do it in O of n, because this operations are constant, and if we iterate each and every element once, we get O of n time complexity. So let's see the algorithm and its demonstration step by step. So here is the algorithm. So here you can see it is only taking one for loop and we are not sorting the array anywhere. So let's see the demonstration of this algorithm step by step. But before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So we'll call this method, we pass in the array. So let's say if we take this array -4, -1, 0, 3 and 10. So the length of the array is 5. So at the start, we simply calculate the length of the array by doing array.length and we store it in integer variable n. So n will become 5. Now as you want to square each and every element and return this array all together in a sorted form, we'll first create our result array. So this result array will store all these elements, squares, in sorted form. So we'll create this new array. We pass in the length as 5. So it will look something like this. So these are the default values of the integer array. So here the idea is we take 2 pointers I and j. So I will start from 0 and j will start from n-1, which is the last index. So it would look something like this, that I is pointing to 0 index and j is pointing to the last index, which is 4. So here if you see, when we do the squares of any negative number, we usually get the result in positive side of the numbers. So therefore this problem becomes complex, because if suppose our array had only positive numbers, then this problem would have been straightforward. We just do the squares, and as the array is already sorted, the squares would have been in sorted form. But here, as we are including these negative numbers, here you can see 3 is greater than -4. But if we take the squares of both the numbers, -4 into -4, we will get 16, and 3 into 3 will get 9. So before doing squares, -4 is less than 3, but after doing square, this number 16 is actually getting greater than 9. So it means when we will return the result of the squares in sorted form, this -4 square will come after 3 squares because 9 will come before 16. So this algorithm becomes very tricky to find the exact position of these negative numbers among the positive numbers. So what we do is we try to fill this result array from the end. So here we create a for loop where k starts from n minus 1. So k is starting from 4 because value of n is 5. So it means we will try to fill this result array from the last. Why we are doing it from the last? Because this is the extreme point where we are sure that what value will come. So for example, this array is sorted. So here will be the smallest number and can be negative, and here will be the largest number. So if we do square of these both numbers and we try to compare them, we will get one value for sure which will be greater than overall all the numbers squares, and we can simply put it here. So let's say for example, if we take -4 and 10, so -4 into -4 will give 16, 10 into 10 will give 100. So if we compare 16 with 100, we are very much sure that 100 is greater than 16, and any number in the array won't get bigger than 100 because we are actually comparing the extremities of this array. So here let's say if it would have been -11, if we would have done the square, we would have got 121, and 10 square is 100. So we are very much sure that if we are comparing the extremities, we will get a square which will be the largest among all the numbers, and we can safely put it in the last index. So this idea will be more clear when we will actually see the demonstration of this algorithm. So I'll just remove this. So here k's value is 4 and it is greater than or equal to 0. So this condition is true. So here you can see why we created these two pointers and we pointed at the extremities, because as the array is sorted in ascending order, the element square won't be necessarily sorted in ascending order. So here what we do is we take the absolute value of the value at ith index and the absolute value at the jth index. So what this absolute method returns is, let's say if the value is -4, it will give us 4. Let's say if the value is -1, it will give us 1. Let's say if the value is 10, it will give us 10. So it gives the absolute value without the sign of it. So here we are actually comparing the numbers without their sign. And why we are doing it? Because this negative sign, when we do square, this becomes minus into minus becomes positive, and we actually do the square of the number which will give us 16. So it's plus 16. So this minus doesn't play any role in the square part. But as these numbers are sorted and we can encounter negative values as well, so therefore we are comparing the absolute values of the start and the end. So here if you see, the math.absolute value of I will be 4 and j will be 10, is not greater than 10. So this condition comes out to be false. So the else part will be executed. So this actually signifies that we can safely take 10, do its square and place it into the end of the result array, because we are very much sure that this value can be safely placed here because we have compared it with the extreme left value. So here we do 10 into 10, which is 100, and we simply put it into the result array at kth index. Now after placing it, we know that we have used this value, so we'll simply decrement j. So j becomes 3. Now we'll simply decrement k because we have used this place. and k is still greater than or equal to 0. So friends, here you can see the importance of doing math.absolute. We are actually discarding this negative signs, and as the array is sorted, we are comparing the extremities of I and jth index, and whichever will be the greater number, that square will come directly here. So here math.absolute of array of I will be 4 and math.absolute of array of j will be 3 only. So 4 is greater than 3. So this condition comes out to be true. So we simply assign the square of this value -4 into the result array at kth index. So -4 into -4 will give us 16. So we'll simply assign 16 here. And as we have used this -4, we'll increment I. So I will point to index 1. We'll decrement k because we have used this spot. K is greater than or equal to 0. Now we'll do math.absolute of -1, which will give us 1, and math.absolute of 3, which will give us 3. So this condition comes out to be false because 1 is not greater than 3. So we can safely put 3's square here, which will be 9. We have used this spot, so we'll decrement j now. So j becomes 2. We'll decrement k because we have filled this spot. K becomes 1 and 1 is greater than or equal to 0. Now we do math.absolute of -1, which will give us 1, and math.absolute of 0, which will give us 0. So 1 is greater than 0. So this condition comes out to be true. And what we do is we simply assign -1 into -1, which is 1, into this spot. We have used this spot, so we'll increment I. I becomes 2. We'll decrement k because we have used this spot. So k is equal to 0. So this condition still comes out to be true. And here we are left with only one element. So 0 is not greater than 0 because math.absolute value of 0 is 0. So this if block condition comes out to be false. And we simply assign 0 into 0, which is 0, to this spot. So it becomes 0. Now we have used this spot, so we'll decrease j. So j becomes 1, which will point here. We'll decrement k because we have used this spot. So k becomes -1. It means it has gone outside of the boundaries of the array. Therefore this condition will come out to be false. And here you can see at the end we will simply return the result. So this is the result where we have squared each number, and after squaring each number you can see the result array is still sorted. And we have used this algorithm without using arrays.sort. So the time complexity of this algorithm is O of n. So we'll simply return the result. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.